All right, let's go ahead and get started. In this video, what we want to look at is the periodic table of elements, and more specifically, we want to take a look at kind of the anatomy of the periodic table, where everything lies on the periodic table. So we'll start by roughly dividing the periodic table into two major sections. This red line that I've drawn here, this zigzag line right here, is the line of demarcation between the metals on the left side and the nonmetals on the right side. Okay, so once again, metals on the left, nonmetals on the right. What is a metal? Well, a metal is something that has luster, it has a shine, it is malleable, it can be pounded or bent into shapes. It is ductile, it can be made into a wire, it can be pulled apart into a wire. It conducts heat and electricity, and that is a metal. Nonmetals, on the other hand, tend to be just the opposite, okay? They do not conduct heat well. They do not conduct electricity well. On the metallic side, some of these you will recognize. For example, silver, gold, platinum. Mercury is a metal, is a liquid at room temperature, but it's a metal. And some of them you won't recognize. So like molybdenum, for example, that you will not recognize as a metal, but is not as a metal nonetheless, because everything to the zigzag line, everything is a metal. Now, let's further subdivide the metals. First of all, let's look at this first column right here. This column right here, also known as a family or group, all columns of the periodic table are known as families or groups, are called the alkali metals. And the alkali metals actually tend to be very reactive with water. In fact, as you move down the periodic table on this side, the reactivity increases more and more and more until you get to francium, which is extremely reactive with water. And the next column is known as the alkaline earth metals. That's alkali metals for the first column, alkaline earth metals for the second column, right? Now, let's move to the central area of the periodic table. We call these the transition metals, and then we'll go to the right-hand side. The last column, you may know, is called the noble gases. These tend not to react with anything because they have what we call an octet of electrons in their outer shell. Halogens are fluorine, chlorine, bromine, iodine, and acetine. The halogens are the column directly to the left of the noble gases. Now, in terms of ion production, let's move over here to the left-hand side of the periodic table. Alkali metals tend to form +1 ions. Alkaline earth metals lose 2 electrons to form +2 ions, right? They lose 2 electrons. So electrons on this side of the periodic table tend to lose electrons to become cations. Let's contrast that to electrons on, or atoms on the right side, like fluorine, chlorine, bromine, and so forth. Notice I've ignored in this discussion noble gases because noble gases don't lose or gain electrons. They have the noble gas configuration of the octet, all except for helium, which has 2, which also seems to be quite stable. But halogens, on the other hand, want to gain 1 electron. And if they do gain 1 electron, they'll get a charge of -1. So in terms of charge, here's how it works. As we move from right to left towards the center periodic table, this column right here, the halogens, is a -1 charge. -2, -3 charge for this column right here. Let's move to the other side. The alkali metals will tend to lose an electron, +1 charge for the alkali metals, +2 charge for the alkaline earth metals, plus then we skip across the transition metals, which are really very chaotic in their charges. But boron and its family or group has charge of +3, carbon ±4. All right. If we go down here to the lanthanide series and the actinide series, these two rows actually belong right in here, right? Well, we usually don't place them in there because if we did place them in there, then they would kind of expand the bottom part of the periodic table, right? The next thing I need to tell you is that on the left-hand side, on this side over here, we have the S block of the periodic table. In other words, electrons or atoms that or have their origin in these two columns will have their last electron in an S block. If we move to this block over here, the periodic table, remember this is the P block of the periodic table. The central area right here is the D block, which is staggered. Go to the video on electron configuration if you don't know what that means. And then finally, the F block right over here, the F block of the periodic table. And that's it. That is the anatomy of the periodic table. I'll see you in the next video. Thank you. Bye-bye.